So here we have the function f of x equals x to the sixth e to the x minus 6. And our goal is to find all of the relative extrema. So remember that this is found by using the first derivative. So we're going to find f prime. And this is a product rule right here. So remember that the derivative of a product is the derivative of the first factor times the second plus the first times the derivative of the second. And then the derivative of the minus 6 is just going to be 0, so we're not even going to bother writing it down. And we know that we want all the points where the first derivative is equal to 0. Now, we're not even considering undefined in this one because this function is never undefined. Its domain is all real numbers. So there's no need to check that. Now, what I'm going to do is I'm going to factor out, so looking at the terms, I can factor out an x to the fifth. My highlighter is too skinny here. And I can factor out an e to the x. So we're going to factor out x to the fifth, e to the x. And we're going to end up with 6 plus x as the inside factor equals 0. So that means a couple things are going on here. This means that x to the fifth is equal to 0. E to the x is equal to 0, and 6 plus x is equal to 0. So any one of those three could create critical points for us. Now, the one thing is an exponential function will never be 0. You cannot raise e to a power and end up with 0. So this one is automatically disqualified. If x to the fifth is equal to 0, this means that x equals 0, so that's a critical point. And if 6 plus x is equal to 0, this means x equals negative 6. So then that's going to be our critical number. So mins and maxes could happen at those values. So now we're going to make our sign graph for f prime. And, our favorite test number, 0, is now taken up because it's a critical number, so we can't use it. We'll live, I guess. We're in calculus. We can live with this now. So I'm going to substitute negative 7 in for x. I'm going to substitute negative 1 because it's close to 0. And I'm going to substitute 1. And remember, the goal is to figure out if our derivative is positive or negative at these values because that's going to tell us increasing and decreasing. And furthermore, is going to tell us whether we're going to have mins and maxes. So I'm going to use the version of f prime that's factored because it is just going to be easier. So there that is. So if I plug in negative 7, and again, you're welcome to use your calculator. I'm just going to do this a different way. We have negative 7 to the fifth times e to the negative 7 times 6 minus 7, which is negative 1. Now, this is negative, this is positive, this is negative. So all I care about is that the result is going to be positive, which means the function is increasing at negative 7. Okay, so f prime of negative 1, same token. So negative 1 to the fifth, e to the negative 1, and 6 plus negative 1 is 5. So this is a negative number, this is a positive number, and this is a positive number. So that means this whole thing is negative, which means the function is decreasing at that point. Okay, now, f prime of 1. Well, we have 1 to the fifth, e to the first, 6 plus 1 is 7. So this whole thing is positive, which means the function is increasing at x equals 0. So we can answer a couple questions here. The function is increasing on two intervals from negative infinity up to negative 6, and again from 0 to infinity. And it's decreasing on the interval negative 6 to 0. Okay, because remember, the critical numbers are where things are in transition. So those are the endpoints of our intervals. This also means that we have a relative minimum point when x equals 0. So I'm going to say 0 comma something. And in the parentheses here, we're going to put f of 0. And we have a relative max at x equals negative 6 and whatever f of negative 6 is. So let's do that off to the side here. So f of x, remember, was x to the 6th e to the x minus 6. So f of 0 is 0 to the 6th e to the 0 minus 6. Well, 0 to the 6th is 0, so this whole thing is 0. So we end up with negative 6. And f of negative 6 is negative 6 to the 6th e to the negative 6 minus 6. Well, negative 6 to the 6th is the same thing as positive 6 to the 6th. I'm just curious what it is. So 6 raised to the 6th power is 46,656 times e to the negative 6 minus 6. And you can approximate that to your heart's content, I'm sure, depending on what the directions are to the problem. So this means that we have negative 6 comma. Let's figure out what that is. So we have that's times e to the negative 6. Whoops, didn't put the 6 in there. And then, yeah, big whoop, we'll subtract 6 from that huge number. It's 109.65. So we'll say this is approximately equal to 109.65. And we'll just assume it's okay to approximate in that one. Usually we want the exact answers, but when they get out of hand like this, it's often easier just to approximate. And naturally, the directions that you're given in each problem will reflect what you are to do. So there's the information, and that's how we analyze that type of a function. So thanks for watching.